Hello and welcome back to another session of Pistonics. It's Byron speaking, and we are implementing the catchit game, which right now is horribly broken. I think basically if you move this here, it thinks it intersects all the time. You score a lot of points. The cool thing is that the prey already moves within the playing field in a random fashion. That's great, but we can't really intersect with it because that is just broken. Where is the intersection code? Here it is. And I think this is something we want to fix right now. So let's look at it. So we draw everything. So the position is basically regarded as the center of the object. And what happens? If you look at X on the left side, then if this X is smaller than the right side of the other object, right? So this is how we want to do it probably. So if the left side, do I want to have little functions that do left, right, top, bottom? Maybe I do. Left, self, scalar. So that's just self position 0 minus self half size. And now we go for right, which is the same, but with plus half size. In the same game we do with top and bottom. Top is 1 minus half size, and bottom is 1 plus half size. Okay, so now we can say if my left is what? If my left is smaller or equal than your right, and the thing is, can these all be ended? Does it all have to be end? That's something I don't really understand. So let's look at y. So if this is like this, and my top is smaller than your bottom, and self top smaller or equal than your bottom. So what? Yeah, so it kind of does something, but is not really there. So what happens if and then if my top is, so do I have to work with my top is smaller or equal than, so then I definitely intersect, and what is my, no wait, stop, my top, that's the, I think I don't know what top and bottom is. So top is minus, so top is really the screen top and bottom is the screen bottom, so that's a good thing. So my top is smaller than your bottom, then I'm in. That's for sure. And now it's also, if you can move this further. And what if my bottom, actually like this. If my bottom is greater or equal than your top, greater or equal than your top, right? This was this thing. Ugh, damn it, you. Yeah, let's visually approach it. as far as we can go. I don't know how far we can go here before it kind of hits it. So if my bottom is larger than your top, then I hit you. And yeah, I don't know. I don't know about these ends here. But yeah. So left, we have what if my right is larger than your left, larger or equal, then I hit you. Then other right. And this is maybe a bit better, even though I'm not sure about this, the condition here. Maybe it's one of these two. Oh. Ah. So from approaching from the right, this seems to work. So the right thing is cool. Boom. From the bottom? No, no. Can I go around it without it going crazy? No. I can. Actually, I can go around it. So that's a good thing. So from the right, I hit it. From the top, I hit it. That's cool. From the left, I don't hit it. And from the bottom. From the bottom, I also don't hit it. So these... And from the top... Damn it, it's only the right side that I kind of can hit, huh? Yeah, look at that. The rest is totally... Damn it, you. Well, it's something. Kind of okay, but still sucks. So probably it's this and stuff. So can we change this a bit? So my left is smaller or equal to your right. Does it make sense? If my left is greater or equal, maybe, huh? Oh, and this, my right to your left, maybe. I messed this up real good. Okay, so if my left is smaller or equal to your right, yeah, then I hit you. If my right is larger or equal to your left, well, I'm not sure about that. Let's try again. Cool, so I appear to be able to hit it from the right now and from the left. And I can still go around it. Cool, from the top, hey. From the bottom, hey, cool. Something happens. What? Voila. Bang, bang. Nice. That officially works now. Yay! We can score points. Did I hit it 29 times already? Amazing. Let's try that again. What? Voila. Cool. So that works. 10 minutes in, we have intersection. Right now, we don't even check the type of object, because it in fact doesn't matter, huh? Cool. So let's create some balls or some obstacles. Right now we don't do that at all. Yeah, so here's the part where we do the scoring. And here's also the part where you would want to create a ball, set up a ball. Do we set up balls in other places as well? No. So we can just put the code here. That's what I'm saying. And we want this ball to be far, we want it to be far enough away from the current hunter position. And I actually also don't want it to fly directly towards it. But anyway, so the obstacle is an object that has an obstacle kind. It has its object part, and it also has a velocity that is a vector 2. And this is basically the advection vector that we add to the position all the time. Yeah, it's a math vector 2 scalar at least pub velocity is this. Cool. So now let's create a new one. I think all we have to do is figure out the kind, the position, and that's it. So the kind, I think it was like a 5% chance to get one of the other kind. So let's do that. So random is our best friend here. Let mut RNGB self RNG borrow mut. I don't know if we needed mut, but probably we do. We'll see. So the kind is relatively easy. I think we can match on this RNG. I don't know what happens if we generate anything. Next to 32. We might just want to use a range here. Huh? Yeah. So let's match on this. Let's say, well, if it is, let kind be a match on RNG, again range from 0 to 1. F32. I think that sets the type. And then we use the value P for probability. If P if P minus 0.05 well, if P larger 0.95, then I think the kind is, do we have an obstacle kind? Yeah. Obstacle kind invisibility switch. Invisibility switch. In any other case, it's obstacle kind deadly. So most of the time we have deadly ones, and that should do something, right? Let's see. Cool, that actually compiles. I'm always happy if that works. Unused variable P. That is true. I think we can fix this by doing it like that, huh? Then it will not tell me it's unused anymore. Yeah. Awesome. And update arcs. True, I will actually, right now I really don't need them. No, wait. I don't use them here, right? So we might actually do it like this, so it doesn't tell me anymore. Cool. That's much better. So we don't miss warnings. Possibly because we just ignore the ones, because we always have warnings. Let's fix warnings as early as possible. Awesome. So there's my probability. I should be able to create these now, or also 2 different kinds. We already paint them or draw them with the respective colors, white and black. And now is just a question, what else we need? We need a position that should be far away, and we need a randomized vector within a certain, or velocity within a certain range. So I think that depends on the field width. So the larger the field, let's do the velocity first. Let velocity be, yeah, it's really like that. So we have x and y itself. It's f64, huh? Yeah. Let's set this up here. So we have a scalar, because then I don't have to deal with that particularly. So it's scalar 2. Actually, it's a position. That is all we need. Position. And then we have RNG gen range. And this shall be from, oh wait, the velocity, right? Which is a vector 2. My bad. Should I have a velocity type? Yeah, I think I should have one. Why not? And that will make it nicer here, huh? Self-explanatory. Even though this could also be a problem, because then people ask themselves, what type is velocity again? They have to remember that it's all the same. That's all a vector, a math vector. Okay, so here we go. Velocity is now a velocity. Again, range from 0 to field. Where's the state? S. Field extend, field 0 by, yeah, there should be some velocity scale. Let's put this in as a constant here. Pub const field velocity scale be a scalar. So we divide by that, or should be, yeah, let's make it a factor. Because that's a scale, huh? Or coefficient. Let's make it a coefficient. I don't know what's better here in terms of terms to use. I think coefficient is okay. If even I know that, then everybody else will probably do as well. So, yeah. I don't know what's too fast and what's too slow. You'll just see, you'll play around with the values. Let's do 0.2. And then we basically scale it to that. And the same thing for y. Field y times the coefficient. So that basically means that along x it can travel faster because there is more screen space, right? And we might even want to, if you have some sort of level, we could say, well, new balls will then be faster. It starts with small balls, but the new ones are faster. And I think, this is just game logic stuff that we can get into to make the game more fun. But for now, I think I'm fine with the static one. The static one can always be there. We might just have an additional scale factor that scales with the level somehow. Have to determine what level should be. Maybe it's amount of balls or something, or blah, blah, blah. We will see. There we go. So now all that's left is the position, and we do not check if we target the. Yeah, I know. We set it up so that the ball may, of course, be pointing towards the player, but if the player is too close, so that it needs, it should have at least, a player should have at least a few ticks. And we don't have a notion of time yet. That might also be a problem, because right now I would say, well, the player should have half a second to react if the ball is aiming his way, right? At least. So in a way, we want to We want to compute the path and then see how fast, how far away it is. But right now we don't do any of that fancy stuff. Well, and then I think in a loop, can I do a loop while, or do a while like this, while true? I'm not sure. Let's just build it. Nah. No, that doesn't work. Rust do while. Does that work? No. I know there's a thing like that, but okay. Rust do while. Should shut it existent, really? While this what? Ah, so we can actually, okay. No, wait. Ah, so you can basically put a scope here. Do stuff. That's amazing. I didn't know that. And that's a do while then. So it will do stuff as a side effect of the check. Yeah. Awesome. So let's try that. So unfortunately we can't have while return anything. Probably that makes sense. Pose is position. You might want to initialize it with something, because the while loop doesn't necessarily do that, right? It can't statically verify that this will run, this will do anything. So let's get a default for this. I think default is implemented for these types, provided we use it. Use std default. Default. Cool. So let's see if that works. I'm not sure. Should be. No. So it doesn't have that. Or it's simply, yeah, I don't know. Maybe default will do it. Nope. It's not implemented for this type. That's unexpected. Okay. Let me do it like that. And get rid of it. Good. So let's do the while thing. And then we can do some vector math again. So we set the position. Actually, it's more like a... Yeah, actually, we want to set the position right away. And compute the distance between the hunter position. And it just shouldn't be too close. And as a first version. But I wonder... We can't use any values that we define in that scope. So what I'm asking is, what would we do in this do part? Yeah, because we are even initializing the position here to something. Damn. Yeah, I don't know. So it should be immutable at least. In a way, here we would set it to something. Oh, actually, we could initialize it with the position of the hunter. So then it's definitely too close. And that's it, huh? So while... let's check the vector math stuff. Distance, right? Vec... Where's vec math? And why do I not see it here? It should be here. Vec math. Yeah. Where is the distance? Oh no, we want to subtract that stuff, right? And then we want to have the length, exactly. So we subtract back to lang. Yeah, so we do a... So while... Yeah, let's get these out of there. Back math. Use back math back to lang as... Yeah, I would actually use that directly. That's sufficiently well done. And then we have a back to sub, huh? Yeah. Back to sub, there we go. So now we can make the computation. If back to sub, that minus self hunter pose, does it copy that stuff? It does. Okay, fine. So it all relies on compiler optimization there. Otherwise, that would be too I don't know, possibly too slow. But it's a good thing, and it's inline. So I think it really relies on compiler optimization. Totally. And that is something that you should do, because you can't write code that is equivalently fast on all platforms. Anyway, so if that back to lang, so is smaller, then I think I would do it in terms of the field area. Or something, or the this length, the diagonal of the field. How do you get the diagonal of a rectangle? Damn it, my math is really, really bad. Diagonal of rectangle, show me. Oh, that's the Pythagoras again. So it's the square root of that. Good. So let's do that. Okay, first we put in some value, and then we put in the square rooted value. But no field exists. Yeah, it's not self, it's S. Cool. So that does something. Let's also create the ball, shall we? So S obstacles push, and then we create a new obstacle with kind, velocity, and position is position. And there we should have some ball that now is spawned for us. Oh, true. We have an object that is an object, obviously, that has a position and a shape, which is a collision shape, sphere, circle. True, sphere is 3-dimensional, right? I'm missing something, am I? And the half size. True. And half size, I think it would be okay if this is just smaller than the hunter. So we say S hunter half size by, that's a magic value again. Obstacle size coef should be 1/3 maybe. Actually not by, but times. Like this. So that should be it, huh? That creates a new object, sets up a velocity that we currently happily ignore. But we shall do this in the next state, basically. Here we check hunter prey intersection. So let's see how that works. No! Syntax. No! And there is probably a comma missing. And that's the case. Nearly there. Has no field name position. True, it just pause here. And there it is. Always screws you if you all of a sudden have abbreviations, and then you don't, and nobody knows anymore. So, oh, panicked. Ref cell already borrowed. Amazing. Haha, we crashed the program. Because we have an RNG here already. Right? Yeah, so why don't we put this up here? And then just use it. That would be neat, wouldn't it? Totally. Yeah. So I think that will work better. Cool. I want to see that ball show up. At least 33 minutes in. Voila. There's one. There's another one. And we have to clamp them to the playing field. I think we don't do that yet. So it's far away enough. Then we clamp it. Self. Clamp to fields. Extend size position. As field. Haha, half size. Let's compute this here. Position, and that generates a new position that we can just use in place. Alright, that should be a bit closer to the real thing. And look, there's a white one. Oh, these, actually it's good to make them that gray because it's a bit harder to see them. Maybe you run into them by accident and then everything gets hidden and you hate the world. Look at that. Beautiful. So let's make this all, I don't want to hard code this stuff. So let's make it relative to the playing field. Bang, 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 bang. Actually, it should also not be on another ball, but that doesn't really matter, I think, because they will probably have different directions, and yeah. Ball to ball intersection, I don't want to do, but it would certainly be fun to do it anyway. At some point, to have them collide with each other and make it even harder for you to predict where the stuff is going to be. I think that's this guy is in for a score multiplier just because he has so many balls. So I think the level really is how many balls do you have in play. This is the level. And maybe even how fast the balls are. So slow balls are worth less in terms of level than fast balls. Yeah, something like that. Jesus. Yeah. Do we see it? Oh, look at this. 99%. It's already kind of... No, 43%. I don't know why it was on 99 just a moment ago. But this is my executable, right? Yeah. As if it was compiling something in the background just a moment ago, huh? Yeah, so 43%, that's the debug version, so that doesn't really count anyway. And you can keep going here. Let's build the release version. Probably this will rebuild everything because something happened. And this will totally kill my computer, and I hope the recording doesn't abort. But as long as the kernel times do not go up, I am fine. So I'm still kind of okay, I think. Phew. Yeah. I think it's a good idea to change amount of jobs to 1 in the middle of the day. But maybe it also will not rebuild that stuff all the time. Ha, I hate it. I am set up to not rebuild anything except for the programs that I work on. But this doesn't work. Because of some reason. Good. So there we are. Let's do the diagonal computation. And I think on the F64 type we can actually call this, right? We have min on it. We probably have SQRT square and square root. Let's see what we have on F64. Oh look, there it is. So that's the release version. I like the game already. Just a few moments and this will be a real game. And then the rest is just tweaking. Alright, so again, let's get F64. Show me what you can do. Power, okay, power 2 is there. Log, all kinds of math stuff. That's the square root. So I guess you have to use power I to do this. Yeah. So let's do power I then. Cool. So let's try that. So where do we have this 50 here? Where's the loop? Here's the loop. And let min distance be s field 0 s field 0 pow to the square plus s field 1 squared, and then the square root of the result SQRT, and then we want a fraction of that, so maybe 1/10. min distance coefficient. Pub const min obstacle to hunter coef scalar, and that's 0.1. Cool. Min distance times the coefficient. So now we have something that scales with the playing field as well. Everything should play to this playing field. How does the velocity do? That does field velocity coefficient. Yeah, so that scales as well. I guess that's already kind of okay. So right now it's 1/10 of the diagonal of the playing field away from you, at least provided I put it in. Min distance. This is something that is sufficiently stable, and we probably want to put this into, we want to set this up ourselves. Because that's part, our engine needs it, but it's dependent on the state. I don't want to make it an optional, just set it up to some value, and we will compute it once we set the state accordingly. When do we set the state again? We set it twice. Yeah, see? So now we want to have a set state function to make this happen properly. Yeah. Or it's part of the state. Fn set state shall be yeah, I think this should be fine. Like this. Then we get a state, which is a state. Let's put this here so we don't screw it up. This will be our new min distance that we can then freely use. We set our own state, a sum state, and we set up our new min distance, which is a scalar. Which is that. And I think we just use the field directly as long as we can. So state field 1, state field 0, state field 1, blah blah blah. Yeah, that's that. Then we set our state. And we are done. So here we probably start with a none and set it later. Let mod e be this, return it, and e set state, and set it like that. Okay, and here we do the same thing. Self set state. Just to get the computation going. This also means that here at the initial creation, the min distance should just be 0 so that it's actually unset. And that is that. Cool. And now we can use the min distance here, and we are fine. So that is self min distance. Nice. Cool. So that should do something useful. Let's see if it even builds, huh? Oh, no method named POW for type F64. What? But it's supposed to have that. It tells me that it has that. Oh, that's nightly. Please don't tell me that this is new. Oh, it's power I. It's not new, but I'm dumb. Pow. Makes sense. Makes sense. There we go. There we got the diagonal of the thing, of the rectangle. I hope that's more or less correct. And it builds. Yeah, they are actually not, they're relatively far away, but not too far away. I think that's kind of okay. I like it. Yeah, and it's definitely always spawning far away from you. This is what you want. Nice, looks good. Seems to be working well enough. It's 21, so the more balls you have, the slower the drawing. After all, 60 updates and 60 drawings per second here. And that is that. Good. Now, yeah, I think we call it a session because that's already something. The next thing would be to implement the movement of the balls. And yeah, maybe we want to implement collision. Let's do this quickly. Let's check for collision. For obstacle in self. No, I didn't mean to stop sudo htop. Yeah, let's quickly do this. Let's check for collision here. In S obstacles. If obstacle intersects with S hunter, then we got a game over. Right? That is that. So this should already work then, even though these things are not moving, but that might be a good thing initially. So we return our own state. Self state take. I don't know if that works because we kind of borrow it already, but I will try. But that's kind of it, right? It's really just we dump our core basically and we are done. If the hunter is hit, the game is over. And probably in that moment, we also want to update our max score. So if state score greater than self max score, then max score plus equals state score. And we update our tries, right? Self tries plus equal, but we do this in any case, plus equal 1. And let's see how that works. No method named intersects found on type obstacle in the current scope. Really? Found an optional state. Yeah, sure, we can unwrap this safely. But I still wonder why there is no intersect. Oh yeah, it's obstacle object intersect with hunter. And now we have a borrow issue. As mutable more than once at a time. Previous borrow self state 0 occurs here. Yep. Makes sense. See, that's what I've seen coming. Yeah, we could set a flag or something. Why not? Modify it later. Yeah, I think that is sufficient. We do the read-only stuff here, or here we can change the state, but getting rid of the state is something we simply can't do here. Yeah, so let's not do it. Let mud is game over is false. So is game over is true. And we can abort this. And have game state. So if we are game over, then we dump the core. Otherwise, it's just an OK. Like this. So that, I think, is sufficiently easy to understand. I think that's OK. So now we can go game over if we collide with one of these guys. Ah, cool. And that's exactly what was expected. It just stops showing us the last game state. And that is it. We are still setting positions and stuff, but as there is no state in the engine, it doesn't do anything. So that is exactly what was expected. And how much time left? 51. Yeah, we can now change. We could now enter some text here that says, okay, listen. Actually, I would like to implement this, but we should do this in the next session. Thanks for watching and have a great day.